Alkenes for AQA GCSE Chemistry. I will cover cracking of alkanes to form alkenes, the alkene structures and the identifying test tube test, then the reactions of alkenes. My idea is that as we go through, you take notes and complete problems. I strongly advise that you do so. Larger alkanes are broken down or cracked to make two products. The first one, a shorter alkane. The second, a more reactive form of a hydrocarbon called an alkene. So this equation takes octane to form hexane and ethene. So octane is cracked to form hexane and ethene the alkene. Of course, the equation should balance. We've got 8 carbons in octane, 6 in hexane and 2 in ethene. And then for hydrogen, 18 hydrogens in octane, 14 in hexane, and therefore 4 in ethene. Look at this potential cracking equation. C12H26 forms 2 molecules of ethene. What must be the one alkane product? Stop the lesson and balance that equation with the correct formula. Okay, so C12, well, we've got 4 carbons on the right-hand side, so we must have 8 carbons in the shorter chain alkane. 26 hydrogens on the left. There are 2 times 4, 8 in the 2 ethene molecules, and therefore 18, C8H18. So that cracking equation should balance, and that's a frequent question in AQA. So the school lab method of cracking involves heating over a ceramic or clay catalyst. So we've got small pieces of clay pot, for instance. You have mineral wool soaked in the larger alkane, and then heat is supplied by a Bunsen burner in 2 places. If you've done this, you know you have to move the Bunsen heat backwards and forwards. A gas is collected. That gas, of course, is the gaseous alkene. So the large alkane is cracked by being heated and passed over a hot catalyst. The gaseous alkene results. Now, the first test tube, if you do this experiment, the first test tube tends to be expanded air. The second test tube is the gaseous alkene. Now, how do we show we've got some gaseous alkene? Well, the chemical test is an effect on orange bromine water. If we mix orange bromine water into the alkene and shake or waggle, then there's an immediate change from orange to colorless. That is the chemical test for an alkene. The industrial alternative is steam cracking. So you mix the large alkane with steam at a very high temperature. The large alkane is cracked into a smaller alkane and an alkene or alkenes. The large alkane, you will remember from the hydrocarbon chemistry of the alkanes, is viscous and less flammable and has few uses therefore. Therefore, there is a low demand for the large alkane. That is, its price on the market is quite low. However, the smaller alkane produced by cracking is more flammable, less viscous, and is therefore a better fuel. And therefore, there's a high demand for this smaller alkane in the market. The alkene, more reactive than the alkane, and is used to make a number of useful products. The first of which we will study later, polymers, for instance PVC. The second, solvents, such as ethanol. Now, the key point is that there's a high demand for polymers, there's a high demand for industrial solvents. Therefore, the value of the smaller alkane and the alkene, or the products that can be made from that smaller alkene, is much, much higher. So the argument for cracking, often asked, why crack? Well, it's economic. The smaller alkane is a better fuel, and therefore there's a much higher demand for it. The alkene can make products such as polymers and solvents for which there is a high demand and therefore a higher price. So we'll move on to the identifying test for alkenes and alkene structures. The test for an alkene: take some bromine water, place that into a test tube, add drops of the alkene to it. We can see here there's the yellow coloration of the bromine water. If we add alkene to it, there's an immediate loss of colour, an immediate decolorization. So let's discuss alkene structures. We're going to compare an alkane to the first alkene. So the first alkene is not methane with one carbon, but ethene with two carbons. So we'll compare it to the alkane, ethane. Stop the lesson. What is the difference, or what are the differences between ethane and ethene? Can you identify two? Stop, come back when you're ready. Okay, so ethane consists of single bonds only, whereas ethene contains one carbon double bond carbon. Ethene has two fewer or two less hydrogen atoms than ethane. There's a naming difference. Because ethane contains single bonds only, it's referred to as saturated. However, the presence of a carbon double bond carbon leads to the labeling of ethene as an unsaturated molecule. So unsaturated equates to possessing a carbon double bond carbon. Saturated equates to having single bonds only. So let's look at alkene structures. Let's look at the first four members of the alkene homologous series. They are ethene, propene, butene, and pentene. Well, I've given you the formula, the molecular formula of pentene, C5H10. Can you deduce the general formula? Stop and come back when you're ready. Okay, well, I'm going to reveal CnH2n. 5 times 2 is 10, CnH2n. So here is the general formula of the alkenes. Can you complete the formula for ethene with 2 carbons, propene with 3, and butene with 4? Again, stop the lesson, complete the formula, come back and restart when you're ready. Okay, so I'm going to reveal C2H4, C3H6, C4H8, simply following CnH2n. So here are a couple of alkene problems. What is the name of this alkene? Well, it's got 4 carbons, 8 hydrogens. It's butene. Which of these 3 formulae represents an alkene? Stop the lesson, work out which it is. Okay. It's got to follow the formula CnH2n. So the only one that does is C6H12. So 2 times 6 is 12. So C6H12 is an alkene. So here's one more problem. What is the displayed structure? That is a drawing showing the bonds and the atoms for propene. Stop the lesson, draw the displayed structure for propene. Come back to check when you are ready. Okay, so the first thing is that propene is C3H6. Prop tells us 3 carbons, ene tells us CnH2n, so C3H6. What does that look like as a drawing? Well, the key point is that we've got one double bond. Very often students draw 2 double bonds. It's an alkene, it's got double bonds. No, it hasn't. It's got one double bond. So you need to take that away if you have drawn it. An alkene has 1 carbon, double bond carbon. So carbon, single bond carbon, double bond carbon. Then each carbon has 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. And the left-hand carbon, so I'm looking at it, 1, 2, 3, 4. So make up 4 bonds by attaching hydrogens. C3, CH, CH2, propene. Alkene reactions revolve around the properties of the carbon double bond carbon, which is referred to as the functional group. So the functional group determines the reactions of the homologous series. That is what's distinctive of this particular family of compounds and molecules. So the reactions of alkenes are typically additions across the carbon double bond carbon. So if we look here at a structure that represents the alkene functional group, we've got carbon double bond carbon and another molecule XY containing 2 atoms or 2 groups. You'll see that X adds to one of the carbons and Y adds to the other. We say there is addition across the carbon-carbon double bond. You'll notice on the left-hand side, the alkene structure, the functional group, the double bond is lost in this reaction, and we have additional single bonds and additional atoms within the molecule. So that pattern is repeated in the next 3 reactions. So the first reaction you need to know about is the alkene reaction with hydrogen. So my example is ethene and hydrogen to form ethane. The double bond is lost and additional single bonds are formed. Atoms join to each carbon in turn. You are also expected to recall the conditions, not only the reaction equation, but the conditions. Nickel catalyst at 60 degrees Celsius. So here's the word equation. Ethene and hydrogen forms ethane. Stop the lesson and write the balanced chemical equation. Okay, so I'm going to reveal. Ethene, C2H4, and hydrogen goes to C2H6, ethane. Now the second reaction, the reaction with steam, follows exactly the same pattern as my model and then reaction number 1 with hydrogen. So here's ethene and water, which I'm writing as H, OH, X and Y. Can you predict the structure of the product? Stop the lesson, draw the structure of the product, come back to check when you are ready. Okay, so of course the OH, the hydroxyl group, joins to one of the carbons. The hydrogen joins to the other carbon. So we've added atoms across the double bond, and the double bond that was in the alkene has been lost. We retain a single bond between the carbons, of course. Now, you are also, as with reaction number 1, expected to recall the conditions. This reaction only takes place at high temperature and pressure in the presence of an acid catalyst. So here is the word equation. Ethene and steam forms ethanol. Can you rewrite that as a balanced formula equation? Pause, come back when you've done it and ready to check. Okay, so I'm going to reveal ethene, C2H4 of course, and water, steam, H2O. Well, there's two ways you'll see ethanol represented, C2H5OH, C2H5OH, or you'll see a pure molecular formula, C2H6O, just counting the numbers of hydrogens, which are 6, 2 carbons and 1 oxygen. So either will be represented in textbooks and in exam questions. Ethanol, of course, it's an alcohol. We'll come across those in the following lessons. Now, the third alkene reaction that you are expected to know about is the reaction with halogens, for which I'm going to take an example, bromine. So here's ethene again with bromine Br2. Can you predict the structure or the displayed structure of the product? Stop the lesson, come back when you're done. Okay, so I'm going to reveal, hopefully you've drawn a single bond between the two carbons, the double bond is lost, and then extra single bonds to each carbon, so carbon-bromine, carbon-bromine. The two bromine atoms are added across the double bond. Now, not an exam question, but it might be involved in background knowledge. This is called 1,2-dibromoethane. 1,2. So the bromines, there's two of them, so that's hence dibromoethane, two bromines, dibromo, but they're not on the same carbon, carbon number 1, carbon number 2. So 1,2-dibromoethane may occur in texts or the context of an exam question. The conditions have to be known, that's room temperature. So ethene and chlorine, another halogen, so not bromine but chlorine, would form 1,2-dichloroethane. Can you write the balanced chemical equation? Stop, come back when you're done. Okay, ethene, C2H4 and Cl2 for chlorine. The atoms simply are all contained, on the left-hand side, are all contained in the one product on the right, C2H4Cl2. So all of the atoms on the left-hand side are then included in the one molecule on the right. That is typical for the addition reactions of alkenes. Now there is one reaction in the specification that is not an alkene addition. It's the complete combustion, which follows the same pattern as for all other hydrocarbons. So if we just look at an example, ethene and oxygen goes to carbon dioxide and water. We have complete combustion to form carbon dioxide and water. So ethene, C2H4, would give us 2 carbon dioxides. We've got 2 carbons, so 2 carbon dioxides. We've got 4 hydrogens, therefore 2 water molecules. Add up all the oxygens, 2 times 4 and 2 times 1 makes 6, 3O2. So just as balancing with other hydrocarbons like alkanes, the numbers of carbons determine the numbers of carbon dioxides, the numbers of hydrogens control the numbers of waters, and then you balance for oxygen. So here's one problem. Butene, complete combustion. Can you balance that equation? Stop and restart when you are ready. Okay, so I hope you've balanced and you've got 4 carbon dioxides because we've got 4 carbons on the left. We've got 8 hydrogens on the left, therefore 4 waters. We've got 8 oxygen atoms and another 4 oxygen atoms makes 12. So we have 6O2. So there is the balanced complete combustion of alkenes. You probably need to do some practice questions, so use your textbook and past papers. If you don't have past papers, then I recommend Physics and Maths Tutor website. Nothing to do with me, just got all the AQA past papers you could want. If you've enjoyed the lesson or found it helpful, please recommend to a friend. Please like, please subscribe. Thanks for clicking.